Today we're looking at 8.9, which is graphs of linear inequalities. A linear inequality is two variables, such as 2x minus 3y is less than 6, is a result of replacing the equal sign in a linear equation with less than, greater than, less than or equal to, or greater than or equal to. So basically what we're doing today is we're combining your understanding of inequalities, which we looked at Chapter 3, and your understanding of graphing, which we've been doing in Chapter 8. And we're just going to combine the two. And so we'll see what that looks like in a minute. An ordered pair, xy, is a solution of a linear inequality if substituting the values of x and y into the inequality produces a true statement. And you already know that. Let's look at this. Let me get a good color here before we move on. Okay. Tell whether the ordered pair is a solution of 2x minus 3y is less than 6. Okay, so again, what we want to do is plug in 0 for x and 0 for y. So this is 0 minus 0. Is that less than 6? Yes. So it is a solution. Okay, look at this one. And let's kind of erase this here. Yeah, there we go. Look at the next one. Is 0, 1 a solution if I plug in 0 for x and 1 for y? That's 0 minus 3. Is that less than 6? Yes, that is a solution. Okay, let's plug in 4 for x, that's 8, and negative 2 for y. That's going to be positive 6 because I have negative 3 times negative 2. 8 plus 6 is 14. Is that less than 6? No. No solution. Not a solution. Next one, plug in negative 2 for x. Okay, I get negative 4 when I do that. Negative 6 for y, I get positive 18. Is that less than 6? No, not a solution. So this is something you've done before. You should be able to do it again fairly well. Instead of equals, though, we're dealing with inequalities. So you have, it doesn't have to equal it, and you got to remember that when you're doing this. It doesn't have to equal this number. It's just got to make the statement true. The graph of a linear inequality in two variables is a set of points in a coordinate plane that represents all the inequality solutions. So just as when we're graphing equations, the line represents all the points that work or are solutions for the equation, with a linear inequality, we're going to do the same thing. We're going to show by graph all the solutions of that inequality. Now it's going to look a little different because notice there's a lot of numbers less than this. And we're going to see that here in a second. Okay, we're going to graph this just like we graph equations. We have to solve for y, and since it's inequalities and solving for y, if we multiply or divide by negative when we're doing this, we have to flip the sign. That won't come up till down here. But here, this one's already solved for y. So we're going to graph this. Okay, we're going to put a point on 4 just like we've done before. 1, 2, 3, 4. Okay, then we're going to go up 2 and over 1. That's our second point. Okay, now when I do this, let me see if I can do something like this. Okay, when I do this, I'm going to get a line that kind of looks like this. Okay, and I want to kind of go all the way with it, and I'll show you why here in a second. Okay, there's my line. Let me get back to my pen. Okay, here we go. I know it's black, but I'm going to put yellow tip on it. There we go. Okay, there's my line. Now, this is, remember, this is greater than or equal to. Okay, this is a solid line, and some lines are not solid when we graph those, and we'll tell you why in a second. But this is a solid line because it has an equal to sign here. That means that every point on this line works in this equation. In other words, it makes it true, every point on the line. But there are also points that are not on the line that make this equation true, and we've got to show that on the graph. So let's look at point 0, 0. Let's plug that in here. So we're going to look at 0, 0 here and see if it makes this equation true. Put in 0 for x and 0 for y. That means 0 is greater than or equal to 4. Is that true? No, it's not. It is definitely not. Okay, but let's put in a point over here that's on this side. Let's go 1, 2, 3. Let's go to 0, 5. Okay, let's go 0, 5 and check it. Okay, so if I check 0, 5, I put 0 in for x, 5 in for y. Is 5 greater than or equal to 4? Yes, it is. So this point, even though it's not on the line, is a solution. So what we have to do with inequalities is we have to shade the side of the line, and that indicates that all of these points on this side of the line make the statement true. Okay? We know that the points on the other side do not, but the points here do. Any point I choose here makes the statement true, and we have to show that by graph. Okay, so that's what the graph of an inequality looks like. Okay, let's do a few more. Let's kind of go back here and get rid of all our stuff so we can start fresh. And I'm going forward, and there we go. Let's do x is less than 3. Okay, if I'm graphing that, I go to x3 right here. Okay, and I'm just going to sketch this instead of doing lines. That is a vertical line, and that was actually pretty good. Wow. Okay, like this. Now, which side of the line makes are points that make the statement? I'm sorry, I've got to go back and do that again. That line. I was so proud of my line, I didn't think. This does not have an equal sign. When it does not have an equal sign, you have to draw a dashed line, okay? Instead of a solid line, you're drawing a dashed line. And the reason for that is all the points on this line do not make the statement true. Okay, when it has an equal sign, you're telling me, when you draw a solid line, you're telling me all the points on the line make it true. But all the points on this line do not make it true. Okay, so we have to make it a dashed line. Now, x is less than 3. That would be points on this side, right? Is 0, 0. Can I try 0, 0? Yes. If I plug in 0 for x, 0 is less than 3. So this works. So every point on this side of the line is a solution. So I would do a better job in shading. I'm just kind of showing you. I would actually shade the entire thing. With a pencil, I would shade the entire side of the line. Okay? Just like that. Okay, let's go back and let's do the next one. There we go. Y is less than or equal to -2. Well, here I'm going to go down to -2. Okay, now it has an equal sign, so that means I'm going to draw a solid line, and I really struggle with these. Let me do this, because this will help. Okay, I'm going to do this. For some reason, horizontal lines kill me on this thing. Okay, and I'm going to do a point here, and that looks really ugly, but you get the picture. Okay, so here what we want to do is look at y is less than or equal to -2. Well, which side of the line has points that work? If I put in 0, this point right here in this equation, does it work? Well, is 0 less than or equal to -2? No. So I'm shading the other side of the line because these points don't work, but points over here do. So I have to shade this side of the line, okay, the entire thing. Let's look at the next problem. If I can back up here. Okay, now here I have to solve for y. Okay, so I've got x plus 2y is greater than 6. I'm going to subtract x from both sides. I get 2y is greater than -x plus 6. Divide by 2. I'm not dividing by negative, so I don't have to change the sign. I get y is greater than -1/2 x plus 3. Okay, let's graph this. Go up 3, y-intercept. -1/2, I'm going to go down 1 and over 2. Okay, so I'm going to have, and it's very hard to do on this tablet, so let's do a line. Let's go, and I'm just going to judge about where it's at. That's not too bad. Okay. Okay, there we go. I did that wrong. Okay, now if we need to look and see which side of the line has the solutions. And I did that wrong again, guys. Look, there's no equal sign. So we do not want to do a solid line. If there's no equal sign here, we got to do a dash line, which means I'm going to freehand this, and it's going to be ugly. Okay, I'm just letting you know it's going to be kind of ugly. So we're going to go through here looking something like this. Okay, that's actually better than I thought it would be. Okay, now which side of the line are points that work? Well, let's look at this equation of ours, and let's pick 0, 0 and see if it works. Okay, Let's plug in 0 for x and 0 for y. If I do that, 0 is greater than 3. Is that true? No. This point does not work. So that means all the points on this side of the line do work. So we have to shade this side of the line. Okay? Now let's do this. Let's do one more here and be done with this page, because we're running out of time. Okay, I've got 4x minus 5y is greater than or equal to 20. Okay, I'm going to subtract 4x from both sides, so I get negative 5y greater than or equal to negative 4x plus 20. Divide by negative 5. Divide everything by negative 5. I get y is less than or equal to, I have to flip the sign, positive 4/5 x minus 4. Okay, minus 4, 1, 2, 3, 4. 4/5, I'm going to go up 4 over 5. 1, 2, 3, 4, 5. Is there an equal sign in it? Yes, there is. So I'm going to have a solid line, and it's going to be terrible, terrible looking. Okay, but you get the picture. Now let's test 0, 0 and see if it works. Plug in 0, 0. 0 for y, 0 for x. Is 0 less than or equal to negative 4? It is not. So these points over here do not work in this equation or inequality. These points do. So I'm going to shade this side of the line, showing that all these points make this inequality true. Okay, and that's what you would do with your pencil. Solid line here, shade this side of the line. Let's go to the next page. Okay, let's write an equation. You have 100 pounds of clay to use for making bowls and vases. You need 5 pounds of clay for each bowl and 2 pounds for each vase. Write an inequality describing the numbers of bowls and vases, possible numbers of bowls and vases you can make. Okay, so if I have 100, I've got, let's call clay X and pound, let's see, bowl X and vase Y. So 5X plus 2Y should equal 100 pounds. Okay? Now, if we're going to graph the inequality, we're going to do it on the next page. We need to find intercepts. So if I plug in 0 for x, what do I get for y? Well, I get 50, right? And if I plug in 0 for y, I get 20, because 5 times 20 is 100. There's my intercepts, and that's what I'm going to graph. Y-intercept of 50, x-intercept of 20. So we'll put a point on 50 and a point on 20. Okay, and if I'm graphing that, let's get something that's going to help, a line. And it doesn't have arrows. It stops right there. Okay, but notice that it wasn't equal. It had to be less than, and I made a mistake of doing that. So it's got to be less than or equal to 100. It doesn't have to be equal to 100. We can do less than 100. Okay, because it's less than, we need to see if a point here or a point over here works in the equation. So let's try 0, 0. Does 0, 0 work in here? Is 0 plus 0 less than or equal to 100? Yes. So we're going to shade this side of the line. So I'm going to color this in, just like this. Now I've got to give 3 combinations that work for us. Okay, any point, and let's go back before we shaded it in. Whoops. Okay, any point here works. Okay, so what's this combination? Well, x's, I can use 5 and 5. I can use 10 and 10 because that's right here. 10 bowls, 10 vases. I can actually use 5 and 20. So any points underneath that line or any point on that line will make that equation true. Okay, and that is a standard word problem that you're going to have today. And that is it.